Okay, this is the rod I'm choosing. So what is the center of mass? Where the center of mass of this rod will be? What is the length of the rod? The length of the rod is L. And let M be the total mass of the rod. So let me define the coordinate axis, this one. So let me take this as reference here. This is the origin. So let me define this as x equal to 0. Where the center of mass of this rod will be is what our question here. So let me assume a small element dx. Let it be at a distance x. Mass of this small element be dm. So we define mass per unit length as lambda. What is lambda? Already I think in laws of motion other chapters you come across. Mass per unit length. What is the mass of this small element of length dx? Lambda into dx. Then what is the center of mass of such objects where the mass is distributed? So it should be the position of that elemental mass of that elemental object. What is x? Position of that elemental structure into mass of that elemental structure by total mass of the system. I think this is not something big. The same old formula. What is that? Xcm equal to m1 x1 plus m2 x2 plus m3 x3 all divided by, in the numerator what we had, m1 plus m2 plus m3. What is that m1 plus m2 plus m3? Total mass of system. And what is dm? Mass of particle 1 and x1. So that was the basic definition. No? The basic definition itself, you see, m1 r1 plus m2 r2 plus m3 r3. So in the denominator what we had the total mass of the system. So like this, for continuous mass distributed object, look at the here mass here. It is from where to where it is available. X equal to 0 to x equal to, the mass is distributed continuously. So then what is the basic definition? First, you define that elemental structure. What do you mean by elemental structure? So which the system is made up of. For a rod, what happens? We just assume a thin strip. There's a thin strip, that one. So of length dx. If you add up all such elements, what do you get? You get the total mass of the rod. If you add up all such elements, you get total mass of the rod. And what is x? X is the position of that elemental structure. Next again, how to put the limits? In what range the mass is present from x equal to 0 to x equal to L is what the mass is distributed. No? So therefore the limits will be xcm equal to xdm 0 to L. Now let's come for what is dm from the definition, x lambda dx and lambda dx. Lambda 0 to L, this will be 0 to L. So integral of x dx, x square by 2, 0 to L, and this will be lambda into integral of, so this will become lambda will get cancelled out, so L square by 2 by L. So where the center of mass of this rod will be, it will be present exactly at the midpoint of the rod is tilting. Like this, what happened? Now we are able to locate the center of mass of an object. This is the basic definition. So you should be very clear about this particular thing. So how to define that elemental structure is what? Very important. Different types of objects you notice and define that elemental structure. So after this, now if the linear mass density of rod varies from one end to another end, let lambda is equal to lambda not x square. Look at the linear density. It is lighter at one end and it's heavier at one other end. No? So how to calculate the center of mass of this rod? So let me take again x equal 0, x equal to L. So this will be the So what is the total length of the rod? Let me define total length of the rod. Let it be L. So I'm going to assume here now small element of length dx at a distance x. So mass of this be dm. Again the basic definition, xm equal to integral of x dm by. So shall I write directly here? What is that? Integral of dm, or total mass of the system it is. So now let's go for dm. What is the dm? Lambda into dx. This is lambda into dx. Where the mass is present, 0 to L. Length of the rod is L. So total mass of the rod we don't know because linear density is varying. So this should be x lambda naught x square dx 0 to L. So lambda naught x cube dx 0 to L. So the limits of this will be lambda, directly I write it, L by 4. So x cube by 3 or x cube dx, how much it will be? L by 4 by 4. X square by dx should be x cube by 3. So lambda naught is there. So lambda naught will get eliminated. So this will become 3L by 4. Now I think it's something very important. Where the midpoint of the rod will be here, no? And where the center of mass is more than L by 2. So it is lying somewhere here. At what distance? If the mass is distributed uniformly, it will be at the midpoint of the rod. If the mass is not distributed uniformly, then it will not be at the midpoint of the rod. So what is O? O, let me define midpoint here. So what is O? O is the midpoint of the rod. So where do it lie? It will be on the right side of the midpoint here. Any reason? Because more mass is present in this region in the second half than in the first half. So therefore the center of mass should lie the right side of the midpoint of the rod. So even if lambda constant, okay, it will come outside integration, get eliminated. You see previous problem. If lambda is variable, substitute that lambda, then you integrate. So what are the type of objects we are going to get? We are going to define the objects where the mass is distributed uniformly and also non-uniformly. But the method is same. If it is non-uniform distribution, substitute that the way how the mass get distributed in the equation, then you integrate. After this, we'll go for the next type of object, a ring. What is the center of mass?